think I saw someone saying that he or she can help. So yeah, so just deep, Gil, you'll be the ref for today. And again, just to reiterate what I said from last week, those who have been participating as our rep will get extra grade for the participation, and I'll keep record of that as we go along. So if you have any question from last week as well, I'll be happy to answer. If you have anything concerning the material, any further clarification you might need, let me know. And anyone who joins in should obviously have his mic off to prevent distraction. So please let me know if you have any question, if you have any concern, draw my attention. And I believe our midterm should be a week or two from now. If you have any question concerning that as well, let me know before we go ahead and start with today's material. Jasdeep, should I just call you Gil or Jasdeep? What works?
Just Jazz is fine.
Jazz, okay, good. So let's quickly pick up from today. If anyone should have any question in the room, please draw my attention and I can have a look at it.
One person asked if the next midterm was Tuesday or Thursday next week.
Yeah, it's going to be on a Thursday because of the time, right? So Tuesday is only 1 hour, so it's not going to be possible for us to have it on a Tuesday. So most likely to be a Thursday, so you guys have 2 hours to go through everything. Is that okay?
Yeah, it looks like that's all right.
So
one other question, sorry. What about the covered material?
About what?
On the midterm.
Yeah, it covers everything we started up until the final day before the midterm. Yeah, so from chapter 1 up until where we got ourselves to. Yeah.
And another question, is it submitted on Canvas?
Yeah, it should be submitted on Canvas, and it's possible that we might proctor it or invigilate it by Zoom. Who just joined with the mic on? Who just joined with the mic on? So if you have your mic on, please take Michael Chen, please take your mic off. Dinzu Wang, please take your mic off. Let me see who also has the mic on. Yeah, so quite apart from Jazz, everyone should have the mic off to prevent the noise from the background, okay? We don't have a better setting, this is the only thing we have, so let's just keep with the basic rules. Jazz, you were asking about something again? Jazz?
Yeah, somebody was asking if it's submitted on Canvas.
Yeah, it should be. It should be submitted on Canvas, and during this week, I'll try as much as possible to see whether you guys can upload files on Canvas just to see how it works for you. So just keep an eye on that. As part of our activities for this week, I'll try as much as possible to have a mock submission, see how you guys can quickly submit maybe one-page equation on Canvas, how quick you can, and let's see whether we might find some difficult, if there's any technical, you can have a look at it. So that will be, yeah. It will be.
还有就是你放技能的时候，别人能看到你那边有没有个针。对啊，对啊。
So, Josh, is there any additional question in there?
Yeah, there's a couple more. One's asking if we'll have any review practice for the midterm.
Yeah, that's a good question. I think one person asked during the course of last week via email. So my best approach is I'll take you guys through what I think might be relevant, and just to reiterate what we've been doing for the past weeks. And I'll basically point out where you guys might want to pay attention more. And if there is any further clarification, I'll let you guys know. So the week after this week might be the review week, and I might have 1 or 2 meetings to take you guys through the most important ones. And my best advice as of now is to keep an eye on the materials that we've been covering in class in terms of the lecture, how do you call it? The lecture video. That might be your best bet for now. Just additional question?
Yeah, the next one's asking if it's gonna be all short answer.
It might be, and it might also contain some equations as well. Yeah. You might have to make sure your equations are up to date, get to know how to derive them, and see how best you can, how best you can go through the equations easily. If there's any twist to it, if I change any parameter, get to know how you can quickly have an intuition behind it and what happens when that parameter is changed. Yeah. Questions?
Yeah, so will there be any older midterms that we can use to practice?
Quite frankly, I don't think so, because this is my first time teaching it. And also what I'm very particular about is trying as much as possible to keep the materials pretty much lecture related, rather than just picking up random questions from textbooks. Somebody might have come across the questions and the solutions, and it might be easier for that person, and someone who has been paying attention in class, if I'm to bring pretty much random questions, the person might find him or herself in a very difficult situation. So my best approach as of now is to use what I did in the second quiz. I'm trying to take you guys back to what we did in class, use the assumptions that we had in class, change 1 or 2 assumptions, see how you guys can think along those lines, rather than having a standard question that might lead to maybe cheating or putting some of you at a disadvantage. So no, I don't think I'll have any standard midterm questions for you to have a practice with. My best approach is let's keep to what we did in class, the lecture videos and lecture materials. Questions? If it's not clear, let me know. If there are any additional questions, surrounding it, let me know as well. Jazz, is there a question in there? Jazz? Hi, Jazz.
One person was just asking if we'll have the full 2 hours or if we're gonna have lecture after the midterm on Thursday.
No, it's just gonna be the full 2 hours. It's gonna be the full 2 hours.
Seems like that's it for the questions for now.
Yeah, so just to reiterate, keep an eye on what we've been doing in class. Nobody can promise you anything that you're gonna get an A if you come to his or her, I don't know, extra class or what's not. My best approach is let's just keep it to class, keep it to the quiz, let's keep up to date, and we should be fine. Okay. So let's quickly pick up from where we left from. Remember, we were still with the Solow growth model, and there were 3 parameters that we were starting with. So the parameters we had here basically were, I might want to call them parameters just so you guys are okay with it. Remember, we had the savings rate from last time. We also had the population growth rate. And we also, lastly, we had the technology. So just if it's not clear from your end, let me know. I can change the markers as well. Is it okay? Can you guys see?
Yeah, it seems fine.
Okay. So we have the savings rate, which we call S, and we have the population growth rate, which we call N. So here, what we realized from last week was the fact that the savings rate, which we call S, is pretty much bounded, right? So we cannot save above a certain limit, and for sure we cannot save below a certain limit. So that's a boundary in terms of the savings rate. Again, in terms of population growth rate, which we call N, there is a particular number that it will for sure not go above or below. So these 2 things kind of limit us in terms of our intuition or in terms of how far we can develop. So savings rates and population growth rates are bounded. They are both bounded. And by bounded, I mean that we cannot grow above a certain level if we are to depend on the savings and the population growth rate. So just by way of reminder, remember we saw this diagram from last week. We saw this guy here. We saw this guy here. We saw this is the K star in steady state. This is the output perhaps in steady state. And this guy here is N plus D. So what we saw from last week was that if you are to change the savings rate, or perhaps if you are to change the population growth rate, you might increase your output in the steady state. An example being, if S is to increase, this line goes up. It increases up until this point, and this guy increases, and this guy also increases. So with an increase in savings rate, our output tends to increase. But we cannot go past above 1, so we have a limit as to how much output we can have. The same thing happens to our population growth rate. We cannot reduce our population rate beyond -1. So we are pretty much bounded in that respect. So just keep an eye on these two parameters and think about them in terms of how they can get you bounded or limited as to how much to grow. What we saw in terms of the technology was that the Z.
Just had a question.
Yeah.
Someone's asking if you labeled Y star wrong.
If I label Y star what?
If you labeled Y star wrong on the graph you drew in the top left?
Yeah, it can be Y star or it can be investment, right? So here I'm just using Y star to make it easier. Remember the same shape. So that's a good question. So what he's asking here is, remember there is a K star here, and I can place Y star here, and at the same time I can place investment star here. This guy here, if it is investment, by taking S to 1, you can just, the same shape will just be Y, right? So I'm just using Y for the sake of making it pretty much concise. Is that okay? So this is investment and this is Y. So the same thing can be represented on the same graph. Is that okay?
Yeah, it seems all right.
Okay. Good. So just keep an eye on those things and please ask questions if you have any. So here, what we saw here was that in terms of the technology is unbounded. We can grow as much as we want, provided the technology is increasing. So Z here is unbounded, it's unlimited. We can increase as much as we want. So this guy here is going to be unbounded or unrestricted in terms of growth. There is no limit to how much technological improvement that we might want to have. So these are the two key things: S and N, how they restrict us; Z, how it does not restrict us. If there is any question, please let me know. Now, if we understand the restriction on this and the unrestriction on that, then we have to separately identify how our economy should go in terms of savings, in terms of population growth, and in terms of technology. And that's what I'm about to do right now. I'm going to tackle savings and how savings help us understand what we call the golden rule of savings or the capital and what's not. Is there any question?
One person is asking, are population GR and savings endogenous?
No, they are exogenous. They are just given to us. So in this model, and that's a good question, and I'll be looking at the endogeneity of the parameters or the endogeneity of the variables when I look at the population growth rate. So everything here is exogenous. Everything in the Solow growth model is exogenously given. Nobody determines the savings rate. It is just given to us as S. Nobody determines the population growth rate. It's just given to us as N. Nobody determines the, how do you call it? The technology is just given to us as Z. When we go to the endogenous growth model, which will start somewhere today or maybe on Thursday, then you tend to see whether it's endogenous or not. Question?
One person asked if capital is endogenous.
Capital, again, is also given to us. Unless, of course, there's a decision that we consciously make, right? That you have a firm, you have consumer, a firm does this, a consumer does that, and at the end of the day, they choose the amount that they would like to go with and all that, and we determine their comparative equilibrium, and we determine their decision endogenously. But for now, the key parameters that are given to us, or the key variables that we have here, are exogenous, right? It's not, don't think of it as endogenous, no. Is that okay?
Yeah, it seems okay.
So let's quickly go back and start looking at what the tech is going to be. Where is my duster? Okay, so let's start by looking at the savings rate. So I'm going to start with the first one, which is the savings, which will determine our golden rule of saving. So here, remember what we said earlier, that S is given to us between 1 and 0. And as S increases, the argument here is as the savings rate increases, the capital increases. And as your capital increases, your Y star increases. And as your Y star increases, what we have is you have a higher standard of living. Now the question here is, should we then advise that everyone should just increase the savings so that the standard of living will just increase for the economy? And the answer here is no. So this is the whole idea of the golden rule, which basically tells us how much to save and how much not to save beyond. So an example here is, a very simple example here is, if you use this argument and you advise someone to save as high as he can, which is 1, when the person says 1, then the person cannot consume today. His consumption today is 0. And if his consumption today is going to be 0, then he's not going to live till tomorrow to see the return on his investment. He's just going to die because he saved everything without consuming. So saving everything is not a good decision to make. Now, what is a good decision to make? The good decision to make will be based on this rule. We start by looking at our consumption. Consumption C star in equilibrium, which is going to be 1 minus the savings, which is the output star. Now, this will help us determine what to save, this equation. To break down this equation, this is going to be C star, which is Y star, minus S Y star. And from what we saw last week, SY star is just the same as, anyone to help us? When you multiply the savings rate by the output, what do we have? Anyone to help me? Anyone?
Total investment, says Jean-Luc.
Yeah, so this guy here is going to be investment. Whenever you multiply the savings rate by the output, you have investment. And remember, we have a production function, or we have the nature of the production function, which is just going to be Z multiplied by F K star minus this guy is S, the same production function Z, F K star as well. So this is going to be our savings. This is going to be our consumption in the steady state. So we are still asking ourselves, what will be the best saving decision so that at the end of the day, our consumption will be maximized? Now, the question here is, again, just to recall, what is S, Z, F of K in steady state? Anyone to help me? What is the savings in steady state? Exactly, N plus K. Again, if N plus D, K. This is what we saw in the steady state. So I realized that Alex and John are responding to it. And of course, this will get to their participation grade. So just keep an eye on that as well. So if this guy is my investment, and I know in the steady state, my investment is the same as this guy, then I can replace this guy here with N plus D. N plus D as a function of K star minus and Z K star this. So this is my C star. So my consumption in steady state is just going to be this function here. And remember what I need to do. I'm trying to ask myself a very simple question. What savings rate, which is the same as what amount of capital, will ensure that my consumption in equilibrium or in the steady state will be maximized? So if you want to write it in an economic sense, you're just trying to maximize your consumption by choosing an amount of capital in the steady state. So here as well, what we are doing is we are trying to maximize our consumption by choosing an amount of capital in the steady state. This function is a function of capital. This guy is a function of capital. So I can just solve this right away. Before I clean it, if you have any question, let me know. Just, is there any question in there?
No question so far.
Okay. So we have this guy here, which has basically turned into this equation. I'm going to maximize C star, which is the same as Z as a function of K star minus N plus D, which is a function of K star. I'm going to choose K star to maximize this function. So the C star, the K star, because I'm maximizing, I put the first order condition to 0. Differentiate this function and equate it to 0. So this guy here, this is Z, I'm going to write the Z here. This is a function of K, so it's going to be F prime K star, which is the first order condition, minus N plus D. This is K star goes away because I'm differentiating with respect to K star, and I put it to 0. So the first order condition becomes Z F prime K star equals N plus D. Apart from Alex and John, the two of you should not answer this. Anyone in the room can answer this question. What is Z F prime of K star? Anyone to help me? Z F prime of K star. What will be that? Exactly, the marginal product of capital, right? This is the marginal product of capital. So basically, for you to maximize your consumption in the steady state, I'm just going to take the first guy, the first person who answered it as a legitimate one. The rest I might have to ignore them. So maybe next time, I'll just go with that as well. So for you to maximize your consumption in the steady state, then the equation basically says that the marginal product of capital should be the same as N plus D. If you're able to do that, then you've maximized your consumption in the steady state. Is there anyone with any question with that? Is there anyone with any question with that, guys? Just?
No question so far.
So this is the golden rule of capital, right? This is the golden rule of capital. What we basically have to do to maximize our consumption in the steady state. So anyone who comes to you and tells you that because savings rate increases capital, which increases standard of living, you should save as much as you can, is wrong, because the person is trying to kill you. This is the best way to maximize your consumption. So keep this guy in mind, and maybe it might come and it might come in the midterm or maybe in the quiz or whatever might be your case. Is that okay? So we have this guy here. Now let's have a look at this equation and let's see how it plays out. We just identified that the marginal product of capital should be the same as N plus D.
We just had a question.
So feel free.
Someone asked if this equation also gives you the golden savings rate, golden rule savings rate, or just the golden rule capital.
It does, because they are related. Because the savings rate goes directly in determining what the capital needs to be, right? Remember this equation? K prime equals, right, 1 minus D, K plus I. But I is the same as investment, which means the same as savings. So basically the savings determine the capital.
Seems like we're okay, thank you.
Okay,
One
sure.
more question, actually.
Yeah.
So you can work back from the golden rule capital and find the golden rule savings rate?
You can work, are you talking about the final solution, or are you talking about determining the savings rate to get the capital and vice versa? Which one are you guys talking about? Are you talking about working from here back to the first point, or you're just trying to say determining the savings rate determines the capital and vice versa?
He's saying using this rule to find the savings rate.
It might be a bit tricky, because in getting the first order condition, we have to differentiate. And if you want to move back from this guy to the first condition that we had, it means you have to integrate back to that point. And integration, you have to add a couple of constants. So mathematically, it might give you some issues. But if you're talking about savings rate determines golden rule of capital, and golden rule of capital determines savings rate, then you guys are absolutely right about it. I don't know if I've answered your question, John. Yeah. So if you have questions, feel free and let me know. So we have this guy here, which basically gives us the marginal product of capital. And remember, as one of you rightly said, the marginal product of capital basically is Z F prime of K, which is K star, which is N plus D. Now the question here is, if this equation doesn't hold, let's take one example. If this guy here is less, it means you've not met the condition to maximize your consumption. So what should you do? What you can do here is, you have your K star. Should we increase the K star to ensure that this equation is met, or should we reduce the K star? That's a question. Increase. Okay, Jane and the other first. Increase. Okay, let's see. If I increase K star, what happens to the marginal product of capital? The marginal product of capital, remember, it is increasing at a decreasing rate. So as capital increases, what happens to this guy? If you increase it, it goes down. So it's not going to work. You probably have to decrease it, because when you decrease it, the lesser the capital, the higher the marginal value of it. And think about it this way. If you're on a desert and you don't have any water to drink, if I give you the first cup of water, how much are you going to value it? If I give you the 10th cup of water, how much are you going to value it? That's the same thing here. So when capital level is so low, the value that we give to it is going to be very high. And the opposite works in the other direction. So when you have this condition, you basically have to reduce it. If you reduce capital, the marginal product goes up, and as the marginal product goes up, this guy comes back to equilibrium. This might be difficult to comprehend, so please let me know if you have any question around it. Questions? Questions? Just, is there any question in there?
No questions so far.
Okay. So just keep an eye on that. Whenever the condition is not met, what do we have to do to capital? Do we have to increase it? Do we have to decrease it? Or what's not? So just keep an eye on that. So we are done with the savings rate and how it helps us determine the golden rule of capital and the golden rule of savings and what's not. Now, the next thing we need to look at here is the population growth rate. Population rate. Now, this is going to be important because it helps us determine a lot of things. It helps us determine the growth rate in the economy in general. Remember, let's take this case, the case of your output. Remember, output divided by N gives us the standard of living. So what I'm trying to do here is to prove that at the end of the day, how much we grow as an economy basically depends on the population rate. So this guy here, remember, is the same as Y equals Y star multiplied by N. This is my Y. And in steady state, this guy is going to be constant. So it's for me to determine how much growth I have in this economy. If this is my current output, my future output might look like this. Y with a bar on it equals the same Y star, which is the same regardless of whether I'm today or tomorrow, because in a steady state, the output is just the same. But in terms of my number of people in the economy, it will go with the same future value. So I have these two guys here. So if this is my current, and this is my future, how much will the output grow in the economy? It all depends on the population growth rate. And let's prove that right away. I'm going to prove that it depends on the population rate. So remember, the last formula that we had for any growth rate, it has to be the future minus the current, or the current minus the past, all over the current. So if this is my equation, it's just going to be Y bar minus Y all over Y. So this will give me the growth rate in my output. But I know what my Y bar is. My Y bar is just Y star with the N prime on it, whilst my Y is the same Y star with a bar on it without N prime, divided by Y bar with a star on it and N here. So just remember, because this is Y star and this is Y star, I end up with Y star coming out, and I have N bar minus N all over Y star bar. This guy here cancels this guy. So what do we have here? Anyone to help us? Just, is there no answer? Exactly, N, right? So we have the N here. So our growth rate in output is the same as the growth in our population rate. You can try the same thing with capital. It ends up being the same thing. We can try the same thing with consumption. They will all be the same as N. So we grow at the rate of our population. Is there anyone with a question in there? If you have any issue with the math, just let me know. Is there anyone with a question in there?
No questions so far.
So this will just be it. So for the attendance, I will try and then ask you guys to do something different today. Send me a direct message. Go to the chat room. Send me a direct message to within the Zoom. You see Farouk Abdul-Salam there. Send a direct message there and write present. Just go in there and write present, and don't write present here. So just go to my direct message and write present. Don't send it to everyone. Yeah. So if you have any question, let me know if there is any question in there. Just, is there anyone with any question in there? Question,
Sorry,
Just.
one person asked if Y star was fixed.
Yeah, Y star is fixed because we are in the steady state, right? So in a steady state, everything is fixed. The value of today is the same as the value of tomorrow, is the same as the value of the day after. So Y star is going to be fixed in the steady state. That's going to be a key assumption. Any additional question?
Somebody's asking if you send they send you an email.
Not email, right? It's just going to be direct message on Zoom, right? Yeah, I think most of you have done that.
One person asked if this is calculating GY star.
This is going to be calculating GY, how we grow as, yeah. You can call it that way, maybe GY star. But one thing I'm very particular about here is in the steady state, the growth rate is basically going to be the same regardless, right? It's just going to be the same. It's just going to be a constant. Alex, was that your question? Do you need any further clarification?
Seems okay.
Okay, then. So let's quickly, so we are done with the population growth rate. We are done with the savings rate. These are the two key things that we realized they will tend to affect how we grow and they are bounded. One key important thing here is one of you was basically asking about the fact that is it going to be endogenous? Is it going to be exogenous? This is where you have to concentrate. So we grow, remember output, capital, consumption, everything here grows based on the value of N. And N, the question here is, how was N determined? Was N determined in the model or was it given to us right away? That's going to be an important question. Was N given to us right away or was it determined in the model? It was given, right? So the fact that it was given to us right away implies that everything here depends on an exogenous parameter, right? So that's why we call the Solow growth model an exogenous growth model. We don't determine anything in this model. Our decisions doesn't matter. Our output is just given to us right away. Anyone with any question? Questions, guys? So this is going to be an important distinction between the exogenous growth model and the endogenous growth model. Now let's quickly go to the output, efficiency, Z. One thing we have here is, now that we know what the N is, we know what the Z is, which is the output, and we also know what the S is. An important assumption that Solow did make here is that if I live in an economy, if all these values here happen to be fixed, this guy is the same as this guy, and this guy, and the same as this guy, we can compare how a country will transition. So we have K star here. We can put Y star here. We can put investment star here as well. We have this guy here is going to be N plus D. And this guy is going to be our steady state value. And this is going to be very important. So please keep an eye on that. This is going to be the prediction by Solow. What Solow predicts that we might find in the long run. So what Solow says here is that at the end of the day, every country moves towards this steady state value. So let's imagine the situation where I have a country that has K, which is here. So I might want to call this country a rich country. This might be Y of K, of the rich country. What Solow is saying here is that if this guy is the same for the rich country, and imagine another country being here, which is a poor country. So Y equals poor. Solow is basically saying that given that the rich country has the same N as the poor country, the same as the poor country, the same as the poor country, then at the end of the day, they all move towards the same K star. The rate of growth here, how this country grow, the growth rate of the poor country, of the rich country, is going to be less than the growth rate of the poor country. So please keep an eye on this and let me know if you have any question about it. The further away, the further away, question?
Sorry, no questions.
Yeah, so the farther away you are from the steady state, your marginal product of capital is going to be high, and due to that, your growth rate is going to be moving at a higher rate. As soon as you get close to the steady state value.
We have one question.
Yeah, sure, feel free.
So, but they both ultimately converge to K star. Just one of them goes faster than the other?
Exactly, yeah. Yeah. And you just have to know which one goes faster than the other.
But they both have the same N?
Yeah, remember I said they all have the same N, they all have the same S, they all have the same Z. If you assume they have different N, then this line wouldn't be the same for them. You have to change this line. Question in there?
How do they have different growth rates then?
Because you are far from it, right? So think about it this way. I have the marginal product of capital, right? This is the marginal product of capital. The very first question here is, what is for every investment that you have in capital, will it be the same for the rich country and then for the poor country? Will it be the same for the rich country and for the poor country? If I invest K, look at the gap here. If I invest K for the rich country, look at the gap here. Will it be the same? Or maybe not getting the question right. Probably you are asking about the fact that we just proved that everybody grows at the rate of N. That is absolutely right. What I need to clarify here is in the transition process, right? In the transition process, one of them goes at a faster rate compared to the other. Is that okay? As they transition towards the steady state, the growth rate of the poor guy, the rate at which this guy catches up is going to be higher than the first guy. Do you want to read the question for me? Just or Tanya? Yeah, feel free.
So when they get to the steady state, they have the same N?
They have the same n, yeah. Because in the steady state, the y was the same for them. Remember, before we did the steady state proof, we assumed that the y star is the same for everyone because they are in a steady state. That's why they all had the n. Is that okay with everyone? But in the transition, one moves at a faster rate compared to the other. Is that okay?
Yeah, just another question.
Yeah.
One person was confused by the concave line. They say they believe that the steady state is determined by saving and depreciation. However, you are showing that SY is equal to Y.
SY equals Y. Where is that? Who asked that?
Alex's question earlier.
Alex, do you mind asking again? Alex? Do you need clarification with that?
He says
Y
on the concave.
Because what? Please, do you mind reading it again for me?
Because you drew Y on concave. Read the first part.
Alex, do you have a mic? I can't read from here. Okay, sure. Just feel free and ask later. Basically, what I'm trying to point out here is the return on investment here is higher than the return on investment here. And the rate at which the output grows is faster here compared to the poorer country. So that's basically what Solow predicts. And that's based on the fact that we assume this guy is the same for the rich and poor country, which is the same for the rich and poor country, Z the same for rich and poor country. So if you happen to be someone who agrees with Solow, then you might find some difficulty in trying to explain why we still have a country like USA, which is very, very rich, and a country like maybe where I come from, maybe Ghana, which is very poor, but the rate of growth in Ghana might not be higher than the rate of growth in USA. It might be very difficult for you to explain it if you want to go strictly with what Solow says. So because Solow is just saying that richer countries will grow, but the rate at which poorer countries grow is faster than richer countries. And it's very hard for us to see this in the data. So just keep an eye on this if you are trying to criticize Solow's prediction. Is there anyone with any question in there as to what Solow predicts here?
One person asked if it's possible for the economy to stagnate before it reaches a steady state.
It might, but remember the assumptions that we have here, all the variables are just given to us, so they're just exogenous. Unless, of course, we bring in actors like consumers and firms and all that, and we have their actions that might lead to stagnations and all that. For now, everything is just given to us. This is what we've been given, and it's given to us as fixed, D is given to us as fixed, and Z is given to us as fixed. So there's nothing about stagnation because we don't make decisions in here. Is there anyone with any question? Tanya had a question. You want to read it?
Yeah, she asked, so would the rich and poor get to the steady state at the same time since
No,
the poor's growth rate is bigger?
They wouldn't get to the steady state at the same time. The richer country might get to the steady state first, but this guy will catch up at the end of the day. But the rate at which this guy will be catching up will be faster. So that's a good question. Yeah. Yeah.
There was another one from earlier.
Yeah.
So G is equal to N is the outcome at the transition state. G is not equal to N.
No, is the outcome under the steady state when we assume the steady state. Remember, because in order for us to get G equals N, we assume that Y star is fixed, right? We assume that Y star is fixed. Remember, we use Y star, and Y star is the same as the steady state value. So G equals N is the outcome under the steady state. Is that okay?
Yeah, I believe that's all the questions for now.
Sure. So if you are someone, again, if you are someone who happens to be going with Solow, then you might have an issue with this. But if you are someone who is trying as much as possible to defend what Solow did, and please keep an eye on what I'm just about to say because you might see it in your midterm. you might say that, hey, even though Solow predicts this, why not assume that the Z is not the same for the rich and poor countries? So it might be that the rate of investment Z in the rich country is greater than rich in the poor country, Z in the poor country. If that's the case, we can explain why we see differences between the richer country and then the poorer country. So please keep an eye on that. If you have to relax any of these assumptions, you can tell us why the richer countries still grow at a faster rate compared to a poorer country. An example here is when Z for the rich country is higher than the Z for the poor country. So if this is Z for the rich country, for the poor country, I might want to assume that Z for richer country is increasing. So they might have a different steady state. That's one assumption. By just changing the Z not being the same for both countries, you can tell us why rich countries grow at a faster rate and at a faster income per capita in the steady state compared to poor countries. One example you can also give here is this guy here, the population growth rate. You might also want to argue that, hey, people in poor countries might not have the same growth rate as people in the rich countries. So the population growth rate in the rich and the poor countries, we see that people in poor countries tend to give birth a lot, whilst those in rich countries tend to give birth to lesser people. So here, when you make this assumption, what you can do here is this will change this line for both countries. It will change this line for both countries, and you might come out with a different outcome in order to explain why we see a higher standard of living in richer countries compared to poor countries, and why we might also see a higher growth rate in richer countries compared to poor countries. You can also talk about it in terms of savings rates. So just try as much as possible to see how these variables do change and how you can use them to make your argument. Is there anyone with any question in there?
One person asks, so G is determined by the distance between the Y curve and N plus D?
What's that? Sorry, can you repeat the question again?
So G is determined by the distance between the Y curve and N plus D?
G, are you talking about the growth rate in output, the rate at which you grow?
Yes.
Yeah, in the transition process, right? You keep on increasing. But at the end of the day, as soon as you reach the steady state, it's just going to be a constant N. Yeah. Remember, regardless of whether you're in a poor country or a rich country, as soon as you reach your steady state, the lines are just the same. The line here is the same as the line here. So it's just going to be Z. But in the transition, you might be growing at a higher rate. Is that okay? Ella, do you have any further questions? Is there anyone with any question in there?
No, it seems like that's it.
Yeah, so just quickly, now just send attendance again. Instead of sending it private, now send it to the entire list. Let me see how it works. I want to compare the two. Send attendance to everyone. Just send present. Just type your name, your full name again, and type present. Yeah. So next Thursday, what I'll be doing here is I'll be relaxing the assumption, and we'll move towards the endogenous model to see how things pan out. And if you happen to have any question, please feel free and let me know. We still have 5 minutes. And for the attendance for last week, this is what I did. I think I tried explaining it to you through the announcement. For every roll call that you do answer, you get 3 points. If you answered all the roll calls, you get an additional 1 mark for completeness. If you answer only 2 roll calls, you get 6 points. So that's what I do. And there's not going to be any point for anyone who answers it late. Yeah, so just feel free. If you have questions, let me know. If it's still confusing, let me know via email. I can go through it again because we still have some time. The next chapter, which is chapter 8, is very short. You can read ahead of time and let me know if you still have questions as to how to compare that chapter to the Solow model and the Malthusian. Make sure you can compare the three. And that'll be it for this week. See you guys probably on Thursday, and have a great day. My office hours is going to be tomorrow. There's the same usual time. If you have any questions, let me know.
Professor?
Yes, Just?
Sorry, it's Manan. So sorry, actually in the middle of the lecture, my Zoom just turned off and I had to sign in again. So I didn't answer your roll call privately. So can I do it right now?
You can, no problem.
Awesome. Thank you so much, sir.
Problem.